Hi and welcome to part 14 of the C tutorial series. So far in the series we've kind of looked at the fundamentals of the language and we've kind of constructed various primitives around that. But we haven't really done anything useful. And one of the reasons we haven't been able to do anything that useful is because we haven't really looked at how to get input from outside of the program. A program isn't that useful if it doesn't take some kind of external input. In some cases a program may not need any external input, but typically in that case essentially the structure of the program is the external input and you'll put the information into the program that you need. But most of the time a program operates on some kind of external input. The first type of external input that we can look at are command line arguments. So for a command line program, the command line arguments allow us to specify how the program will operate. I don't know if you remember, but when we started the tutorial we used to use this function signature for our main function, and then I remembered that you don't actually have to use this long function signature, you can just put a bracket here. But what this function signature is for, so it's an alternative to just writing main bracket bracket, this is so that you can receive and process command line arguments. So just imagine this is a normal function. These arguments here, argc and argv, are usable then within the main function. And what are they? Well, argc is just the argument count. So that is the number of arguments passed to your program plus one, actually. So by convention, the first argument is the name of the program. So that's just the number of arguments passed to the program plus one. Argv is the arguments themselves. And what this is a pointer to a character pointer. And now that you know about pointers, we'll just explain what that is. So argv is a memory address, and at that memory address there is a character pointer. Character pointer is 8 bytes long, so we've got a character pointer here, and that actually points to the first command line argument, which by convention is the name of the program. So it's kind of a special command line argument, it's just the actual name of the program. And that's at index 0. Because this is actually an array. So while this is a pointer to a character pointer, so here we've got argv is an address that points to a character pointer. That character pointer is an address of a string, essentially, a character buffer. So what argv is an array of character buffers. So we have another pointer to another character buffer here and another one here, and this will point to some string, the name of the program, hello world. This will point to some string, the first argument, I don't know, a number 3 maybe, and this will point to a string, whatever, x. And that might be confusing, so we can basically just, if we say argv0, that will be a string, a C string, which is the name of the program. Argv1 will be the first argument that we pass to the program. It'll be a C string which passes the first argument. So argc is the argument count. So if our program was called hello and we invoked it with the string, the string 3, it's just a character string, right? Although it is a number, it's just a character string when we type it on the command line. Then argv0 would be the string hello, and argv1 would be the string 3. And argc, the count, would be 2. So it's pretty straightforward. Once I show you an example of it, it'll be really straightforward and obvious. So let's have a look at an example of it. So we're going to start just by writing this new function definition for main. So it's int argc char argv. And the first thing we're going to do is we're just going to print out what argc is. So it's an integer, and then we're going to print out all of our arguments. So for int I equals 0, I is less than argc, I plus plus, we're going to print out, and as I said, each of these is just a string. So we can say arg d, and then we'll have the string itself. So that's I, and then argv I. And that's it really. We're going to return 0 at the end of our function. Now if we run that with no arguments, as I said, there is always one argument, and that is the first argument, which is the name of our program. So our program was called hello args, and that is always what the first argument is. In fact, including the full path that we use to execute it. So if we were to execute this using its full path, which would be home ash ctutorial 14 command line args hello args, then arg0 would be that full path, if you see what I mean. Right. So let's now execute hello args with some more arguments. First of all, just one. If we put a string in there which says yo, then arg count is 2. Our first argument is the program name, and the second argument is the string yo. And this is pretty simple. Wherever there's a space, then each of these will be counted as a separate argument. So as you can see, it's very easy actually to obtain those arguments, and then you can process them accordingly. As you can see, it's completely trivial to access the arguments. We need to use the arguments, and one of the things that we'll need to do, if we pass in a number, what we get, of course, is a character string containing that number. So we need to convert that to a number, to an int, or to a float, or whatever the actual type of the argument is. Another thing that we usually have to do is just check that the number of arguments we get is equal to the number of arguments that we expect to get in our program. And you're familiar with this from using command line tools, of course. And if we provide an argument that's unexpected, like a switch that doesn't exist or a command that doesn't exist, then we want to print an error. And to do that, we'll just use typically the string comparison operator, something like that. So first of all, we probably want to do something like this. If argc is not equal to 2, that's if we had one argument, because argc will always be 1, which is because the program name is an argument. And if we just had one argument to our program, then we'd want to check if it's not equal to 2, then we haven't got the precise number of arguments that we need. So then we just do something like exit with an exit code that's non-zero, exit 1. So that's typically how we would process the just the argument count to check that we've got the right number of arguments. Now that we've got the right number of arguments, imagine that our program expects a single integer. So let's just look at how we would process an integer. So you've got to imagine we've already checked the argument count. And now we know that our integer is going to be in argv1. So argv0 is the name of the program, or whatever name we give it in our compilation command line. argv1 is going to be the integer that we pass in. And in order to check that it is actually an integer, now traditionally we could have used a function called atoy, but now there's a better function called stringtol, string-to-long, strtol. And we're going to use that because that's more robust and can tell us where in the string the error is if we try and convert it to an integer. Although it actually converts to a long. Bear with me, let me show you what it is. So first of all, I'm just going to get rid of this because you know what's going on with that. And I want to show you what the function prototype for string-to-long looks like. So it returns a long. It's called string-to-long, and it takes actually 3 arguments. I'm not going to be able to fit them in here, so I'm just going to list them down here. So the first argument is and it's actually a const char, and I think it's called an end pointer. Of course, it doesn't matter what it is actually called in the functional definition. There's also another keyword in there called restrict to do with the way that pointers are used, but we won't bother about that. The const isn't really that relevant here but I'll just point it out and we'll talk about it later in another episode. So const just declares that this argument is read-only. Now that's useful because if you see a function that accepts an argument that is const, then you can assume that that function is not going to change its value, although there are ways to override it. So, I mean, personally, I don't think const is that useful for that reason, because you can override it. But a lot of people use const. So at a glance, we can say, okay, string to long does not change this pointer. It wouldn't matter if it did anyway, if it changed the value of it within the function, because it would only be changing the value. But in any case, that's what const means. So that's essentially read-only within the function. Okay, it doesn't change our string. And this first argument is the string that we're trying to process. So this is our first argument that we're trying to process. Now the second argument is I think this is called endpointer, if I remember. And this is a pointer to a character pointer. So it's actually the address of some character string. And this is going to be modified, it's not const. I mean, it not being const doesn't mean it is going to be modified, but in this case it will be modified. And what endpointer stores is, when we pass in a string to be converted, that we think contains a number, string to long will try and do the conversion. And if that conversion fails, it will point to, within that string, it will point to the first character that it failed on, which is useful because then we kind of print out what went wrong with the conversion. And the reason we pass in a pointer to pointer, if you remember back to the pointers tutorial, well, we're actually trying to modify the address that's stored in a pointer, so we need to go to where that address is stored and modify. The third argument, and it's just an int, is the base. And that is just the base that the number is encoded in. So if you look at my, I've got a tutorial on my YouTube channel about binary numbers, then that would, binary numbers are base 2. So you can actually pass in numbers in any base you like, any numerical base. We would typically be passing in the number 10 for a decimal number. So that's the function prototype for string_toll. And so we pass in the string we're trying to convert, we pass in a pointer to some character pointer that we've got, so we can check the result, and the base that we're trying to do the conversion. String_toll will return the conversion, so if we pass in the string 3, it will return the number 3 as a long. So if we want that as an int, we have to check that that's not bigger than an int, but you know, we'll leave that to later. And we pass in the base. And when something goes wrong, what we'll do is, after we've called this, we'll check endpointer, and if everything's gone correctly, endpointer will point to the end of the string. It will point to the null character in the string, so we can check that. And if that is not true, then we know that there's something gone wrong and we can observe that. Let's look at that as a program and see how you can use it to actually process a number. So we're going to start with our main function like this, and you'll notice that we're including standard lib and limits.h. We need those for string to long, and if we look in the string to long man page, it says we need standard lib and limits.h, so we include them. We need standard.io.h to print stuff out as well. So the first thing we're going to do is we're going to check our arguments and check that there's exactly 2. So if our argument count is not exactly 2, then we're going to print out usage, a new line, a tab. We're going to print out our program name, and we're going to print out how we actually use the program. Once we've done that, we're going to exit the program with a non-zero return code. So if we just try that and we don't provide the right number of arguments, we get this usage message, which, you know, you're familiar seeing that on programs. If we do provide an argument, then we don't exit and we carry on. So what we're going to do is we're going to try and be quite robust about processing this input. So first of all, we're going to get a long called x, and we're going to call string to long. Now we're going to call it
the first argument is the string that we're trying to process, which is argv1. Argv0 is the program name, so that will be in arg, whereas we want to process this, and this is argv1. This. Now, the second argument has got to be a pointer to a character pointer where it will store the character which follows the attempt at conversion, which will be an invalid character if there's an invalid character in the string that we're trying to convert, or it will be the end of the string if there was no problem. So we need a character pointer, and we're going to call it end pointer and give it the initial value null. And we need the address of that pointer, because we need a pointer to it. So we're going to take the address of end pointer. That just means that then it's going to change the value of this pointer after it's called. And the base, which is the third argument, is base 10, it's decimal. So once this is done, we now want to check. Yeah, we should make an assignment there, so we're assigning the result there. We want to check what's happened. So if everything has worked fine, then there'll be no errors, and end pointer will point to the end of the string that we're trying to point to, which means that the value of end pointer, which will be the first character after the conversion, and if there was no invalid characters, that will be the end of the string, will be equal to 0. So if it's not equal to 0, so we're dereferencing it, we're looking at the first character of that, essentially of this end pointer, which is the first character after conversion. If it's not equal to 0, we know there's an error. But there's another condition where an error can occur as well. So we can say or, and we're going to use something called error number. Now, just bear with me. We need to include this thing called error number, because stringtoll also sets the error number. Now you see error number used a lot. And when we include error number, we'll be defining this global variable called error number, which is an integer. And we're going to set it to 0. And we're going to set it to 0 before we call string to long. And if string to long has any problems, then it's going to set error number to non-zero. So we can then check for that by saying if or error number. Obviously, if error number is 0, then that would be false. So this would be evaluated false, and we'd ignore it. If error number was anything non-zero, this will evaluate to true, and we'll go into our condition. And if we look in the man page for string to long, we can see what it does. And what happens if no conversion could be performed, 0 is returned, and the global variable errno is set to einval. If an underflow or overflow occurs, errno is set to erange. Okay. So what we can do is we can then say, we'll check that first. If errno equals einval, no conversion could be performed. I need a bit more space. Else if errno equals erange, conversion out of range. In the case where we pass in an invalid number, but that begins with a valid number, error number won't be set. So what we're going to do is, in this case, if we're out of range, we're actually going to exit. But if we're not out of range and the conversion just messed up, we're first of all going to print where the error occurred. We're going to print the string, which is pointed to by end pointer, and then we're going to exit. In fact, if no conversion can be performed, we just exit as well. So let's test that out. We're going to call int arg with a valid number, and we've not got any errors, so nothing happens. If we call it with a complete non-number, we get no conversion could be performed, and we exit. because this is just a complete non-number. If we call it with a number that then has invalid characters in it, then we're going to get this error number is not going to be set. The conversion will succeed, but we'll get we'll essentially get this number, that number 434334, but we'll have this error because the error occurred at this character here. So we've actually now covered all of the possible cases where an error can occur. And so at this point in our code, what we will have is a valid long. Conversion is not out of range. Let me show you the out of range conversion as well. So a long obviously can only store a certain number of bits. If we keep making this number bigger, eventually we'll get conversion out of range. We can't store that number in a long. And that will be clamped then to the largest number that a long can store. But in our case, we're going to exit. But you could do something else. So now we've got a valid long which is within range. We want to convert that to an integer. So what we can do is, we could say if x is bigger than int max, which is included in our types.h that we included at the top here, oh sorry, limits.h, then we could say past value is too big for an int, and then exit. Otherwise, everything is completely successful, and we'll print out our value of x as an int. So x is everything successful, x is, and then the value of x cast as an int. So let's now have a look. If we pass in a valid number, we get the value of x. But let's have a look if x is too big to store in an int. Past value is too big for an int. So if we want to have a look what an int max is, we'll just print that out. We need to put something in. That's our maximum integer that we can store in a 32-bit integer. So any number bigger than that, and we're going to get a complaint. So if we pass in 2147483647, it's fine. If we pass in 48, then the pass value is too big for an int. Now that may seem quite elaborate. We've gone through all of the kind of mechanisms and all of the checks to check that the value that we've returned is actually an integer. Now normally what I would do is I would wrap all of this up into a function which would say something like get integer, and it would take a character, a string as an argument, and then it would print to say standard error or whatever if there's an error. Or what I might do is wrap it in a function like this that will return 0 if there's no error, and I'll have a second argument in which the result will be stored. And then once you've written that, you only need to write that once, and you can use that, call that function over and over again for your. You can call that function over and over again for your arguments. I know it's a little bit involved, but if you really want to check that everything is valid, then you can do that. I mean, you'll see lots of programs where they don't actually bother to check, but it is worth going to the effort of checking, especially if, you know, once you've written the function to do it, it's simple. You just you include that in your program next time.
So that's string to long. It's pretty straightforward, a little bit convoluted, but like I said, if you wrap that up in a function once and just reuse that every time you use your program. As an exercise, I'd like you to look at the string to double man page, and you'll see that it's basically identical to string to long and how you use it to get a double from a string input, except that there's no base parameter and it returns a double. So you should easily be able to modify the program that's in the Git repository to process a double instead. Otherwise, a string remains a string, and you use string comparison to kind of check whether or not a string argument that you pass in is what you expect. There is a function called getOpt, which is part of the standard library, which has been designed to help you deal with the case where there's lots of command line switches, you might want to look at the man page for that, man get opt. We're not going to look at it here. By this point, I expect that you should be able to read man pages, and you should know enough about C now that you should be able to read, say, the man page for get opt and work out how to use it if you need to use it. Alright, well that's it for this episode, and I'll see you next time.